Greetings everyone, you are welcome to this video tutorial. In this video tutorial, we will talk about pointers in C++ and this is the part 1. There are two parts of this tutorial. Now let us see what is a pointer. A pointer is a variable that holds the memory address of another variable of same type. Very important to note, it holds the memory address of the variable which is of the same type as the type of the pointer. Now this memory address is the location of another variable where it has been stored in the memory. So if a variable is stored at some place, the address of that place will be stored in the pointer. And till now we were accessing the value of a variable by its name, and now pointer provides a way to access a variable indirectly, that is using its address instead of its name. So if I say int a, so in the memory 2 bytes will be allocated to the variable a, and suppose this is the beginning address of this of the space which is allocated to a. Now so pointer variable will contain this address. It will contain the address of a variable, that is the address where the particular variable is stored. So every variable and every function in the program starts at a particular address. You must know this, that all the variables and functions, they start at a particular address, and a pointer variable is used to store this address. So if variable a, you can see, starts at this address, so pointer variable of type integer, because this is also an integer variable, will hold this address. If the pointer variable wants to point to this variable, it will hold this address of this variable. Declaration of pointers. Now the syntax for declaring a pointer is, we give the data type first, then star, and then the variable name. Where the data type is any valid C++ data type, and star, it means pointer to, and variable name, it can be any valid C++ identifier. So if I say int star ptr, it means ptr is a pointer to an integer. That is, because it is of integer type, it is a pointer to an integer. That is, ptr can hold address of an integer variable. So if we look at this diagram, suppose x is an integer variable and it holds value 10, and suppose ptr is a integer type pointer. So it can contain the address where the variable x is stored, and so if this is the address where the variable x is stored, it will contain, ptr will contain this, so ptr will point to x. Now float star y, here y is a pointer to float, that is y can hold address of a float variable. Char star z, here z is a pointer to a character, that is z can hold address of a character variable. Now it is important to note that data type of a pointer determines the data type of variable whose address it is going to store. So if it is an integer type pointer, it will hold an address of integer variable, and if it is a float type pointer, it will hold an address of float type variable, and so on. So you have to be very careful while assigning an address to a pointer. Now address of operator. Address of operator is represented by this symbol ampersand. It is a unary operator and it returns the memory address of its operand. And here the operand is a normal variable. So we look at the example. Suppose int x is equal to 10, which means x is a variable of type integer. Suppose this is a variable of type integer and its value is 10. So you see that this variable is the beginning address where this variable is created in the memory is this. This is the beginning address of x. So if I say cout ampersand x, so the output will be this address. The beginning address at which the variable x is stored. We can see the output is same as this address. So this statement will display the address where the variable x is stored in memory. So I can display the address where the variables are stored using the operator, address of operator, which is represented by the symbol ampersand. Initialization of pointers. A pointer variable can be initialized by storing the address of variable to which it is going to point to. So let us take an example. Suppose int x is equal to 10. X is a normal integer variable, you can see here, and it holds value 10. Now if I say int star ptr is equal to ampersand x, it means that PTR is a pointer of type integer and ampersand means address of X. So it can hold only addresses. If it is a pointer type variable, it cannot hold simple values like 10, 20, 30. It can hold only addresses. So I have to give a command ampersand X. Ampersand X means address of X. So if the beginning address of X is suppose this, so this command will store the address of X in PTR. So PTR will now hold the address of X. So X is a variable again which contains value 10 and PTR is a pointer to an integer and it stores the address of integer variable X. The address of X can be stored in PTR using address of operator. So we can store the address of any simple variable in a pointer variable using address of operator. Dereference operator, which is represented by the symbol star. Again, it is a unary operator that returns the value stored at the address pointed to by the pointer. So here the operand is again a pointer variable. So let us take an example to understand this point. Suppose int x is equal to 10. It is a normal variable which holds value 10. Now if I say int star ptr is equal to ampersand x, it means ptr is a pointer type variable and it is a variable of type integer. So if I say ampersand x, it means address of x. So it will give the address where x is stored and this address will be stored in PTR. And if I say cout PTR, so the content of PTR you can see is the address of x. So if this command is given, the address of x will be displayed. And suppose I want to display the value which is pointed to by PTR. So I will give the command cout star PTR. So star PTR will display, this is a dereference operator, so it will display the value which is stored at this address. You can see the value stored at this address is 10. So cout star PTR command will give the output as 10. So this is a dereference operator. You can see this is a address of operator which gives the address of a variable, and this is a dereference operator which gives the value which is stored at the address given after it. So PTR contains the address of x, so it will give the value which is stored at the address of which is stored at this address, that is the value which is stored in x, and this value is 10. So output is 10. Now we can use we can also use PTR to change or display the value of x. So now there are two ways of displaying the value of x. You can see I can give the command cout x, that will also display 10. And if I say cout star PTR, this command will also display the value stored in x. Pointer arithmetic. Two arithmetic operations, addition and subtraction, may be performed on pointers. It is very important to note that when we add 1 to a pointer, we are actually adding the size of data type in bytes. It is not actually 1, but it is the size of the data type in bytes the pointer is pointing at. So for example, if the command is int star x, it means that x is a pointer of type integer. And if I say x plus plus or x is equal to x plus 1, so in both the cases, if the current address of x is 1000, then x plus plus statement will increase x by 2 bytes. Why 2 bytes? Because it is a pointer of type integer. So it will point to 1002 and not 1001. So 1 will not be added, 2 will be added, which is the size of int. And if it was float, then 4 will be added to the current address of x. It will point to 1004. Now let us understand all the four operations. Basically addition, subtraction, and then incrementation plus plus and decrementation minus minus. These are the basic operations which can be performed on pointers. Now the arithmetic operation on pointers, they are performed again. This is I'm explaining you. This is in terms of size, is in bytes of data type. That is, if int star x, then x is a pointer of type integer, then x plus plus will increase. Will not add 1 to it, but it will add the number of bytes of the data type to which it is pointing. As it is pointing to integer type variable, int type, so it will add 2 to its original address. So if the address is 1000, then x plus plus statement will increase x by 2 and make it 1002. It will not be 1001, but it is 1002. Now let us understand it more deeply. Now let us suppose there are two variables, x is equal to 10 and y is equal to 20 of type integer. This is the memory representation of it. Here x is a variable of type integer and it has value 10 and it is stored at this address. Then y again is a variable of type integer and this is the beginning address of y and the value contained in y is 20. Now if I say int star ptr is equal to ampersand x, so this statement will do what? It will store the address of x in ptr. So you can see here this address is stored in ptr. Now if I give the command cout star ptr plus plus, what will happen? See, in this two operations are being performed. The pointer is being incremented and we are displaying it also. So in this case, it will first cout star ptr and then ptr is incremented. We can again understand this. This command will increment pointer and it dereferences unincremented address. You can see dereferencing is done before the incrementation. So this command will give the value stored at the address contained in ptr and then it increments the address stored in ptr. So when I say cout star ptr, you can see the address of stored in ptr is the address of x. So when I say star ptr, it will display the contents which are present at this address and this is 10. So 10 will be displayed and after that ptr will be incremented and suppose that they are at consecutive locations. So ptr will contain the address of y now. So see. So because it is of integer type, 2 bytes will be added to it and it will point to the next location, which is the location of y, variable y. Now if the command is cout star plus plus ptr, then what will happen? In this case, first the pointer is incremented and then the dereference operator takes place. So you can see it increments, this command increments pointer and dereferences incremented address. That is, this command increments the address stored in ptr first and then displays the value stored at the incremented address. So you can see here, suppose this is my diagram, the initial position where ptr is pointing to x. So if I give this command, so ptr two bytes will be added to ptr and ptr will start pointing to y. And then the value which is stored at this address is displayed and this value you can see is 20. So 20 will be displayed. See, I am taking for every example I am taking this as my initial layout. So in this case, first my address is being incremented. You can see here the ptr contains the next address and then the value stored at this address will be displayed. So 20 is being displayed. Now let us see what happens if I give the command cout plus plus star ptr. Very important to understand. In this it functions like this, plus plus and then in the bracket it is star ptr. So it dereferences pointer and increments the value it points to. That is, the command first gives the value stored at the address. You can see star ptr is in brackets. So bracket, according to this, BODMAS will be performed and star ptr will be performed first. So it will give the value which is present at this address. And if I take this as my initial situation, so ptr is pointing to x. So star ptr is 10 and then 10 is incremented by 1 using the increment operator. So you can see here, then 10 will become 11 and 11 will be stored at x. And this value 11 will be displayed also. So you can see how putting the sign before or after totally changes the situation. So you have to be very careful while using pointers. Now if the command is cout star ptr within brackets and then plus plus, in this case it dereferences pointer and post increments the value it points to. In this case, it was pre-incrementing the value. Here it will post-increment because we have a post-increment operator. So this command gives the value stored at the address contained in ptr. So you can see here in ptr, the address contained is the address of x. So it will display first the value. So 10 will be displayed and then it will increment the value by 1. So then the value of x will become 11. So 10 will be displayed first and then the value is incremented. X will now contain 11. Now let us talk about pointers and arrays. C++ treats the name of an array as a constant pointer which contains the base address, that is address of the first location of array. So if you take an example, if we declare an integer type array and its name is x of size 10, then in this case x is a constant pointer which contains the base address of the array x. So the name of the array always contains the base address of the array, that is the address of first location of the array. We can also store the base address of the array in a pointer variable, and it can be used to access elements of the array because array is a continuous block of same memory locations. So let us take an example. Suppose we have an array, integer array of size 5. X is the name of the array. So you can see here, this is my array of size 5 and these are the contents 10, 20, 30, 40, 50. The name of the array is x. So I can directly write down int star ptr is equal to x. Why it is possible? Because x is also a pointer which contains the base address of the array. So if the base address of the array, my array starts at 1000, suppose this is a dummy address. So my ptr will also contain this address. There is no need to give ampersand because x is also a pointer. So the base address of x will be stored in ptr. And now we can also write, and this command can also be written as int star ptr is equal to ampersand x0. So x0 is the first element of the array. So I can use address of operator with this element. It means address of first element, which is again 1000 in this case. So these two commands are same. Whatever way you find convenient, you can use that command. Now in the previous example, you have already seen that ptr is a pointer which is pointing to x. It contains a base address of x. Now if I say ptr plus plus, this command is valid. What will happen when I say ptr plus plus? Now 2 bytes will be this, since this is an integer array and this is a pointer to an integer. So 2 bytes will be added, simple arithmetic addition. So 2 bytes will be added to it and it will start pointing to the next element of the array. You can see now the address is 1002 and ptr is pointing to the next element. But if I say x plus plus, this is invalid. Why this is invalid? Because x is a constant pointer and the address stored in x cannot be changed. This is a variable pointer and the address stored in it can be changed. So again it is the same thing is written, x is a constant pointer and the address stored in it cannot be changed. But ptr is not a constant pointer. Thus the above statement will make ptr point to second element of the array, that is 20 in this case. Now the content of the array x can be displayed in the following ways. We can say for int I is equal to 0, I less than 10, I plus plus, cout star ptr plus I. So in the beginning I will be 0. This will become star ptr and the ptr is pointing to the first element of the array. So it will display 10. When I will be incremented, this will become ptr plus 1. As when 1 is added to ptr, actually 2 bytes will be added to it and ptr will start pointing to the second element and star ptr will display the content which is present at this position, that is 20. So when I is incremented again, I will become 2. This will become ptr plus 2 and it will start pointing to the next element and the content of this element, that is 30, will be displayed. This loop will work like this. And it can also be displayed using for int I is equal to 0, I less than 10, I plus plus, cout star ptr plus plus. So if I say cout star ptr plus plus, this is a post increment operation. So it will first display the content which is present at ptr, as ptr is pointing to the first location initially. It will display 10 and then ptr will be incremented and ptr will point to the next location, that is 20. So this loop will continue till I is less than 10. We can also use the following loop for int I is equal to 0, I less than 10, I plus plus, cout star x plus I. So x is a pointer which is a constant pointer which contains the base address of the array. So if I add I to it, in the beginning I is 0. So star x will display the first element and then I will be incremented by 1. So this will become x plus 1, that is 2 bytes will be added to it and at this address the content present is 20. So this in this way we can use this loop till the end of the array, and all the elements of the array will be displayed. Now let us talk about pointers and strings. We can also handle the character array using pointers. Now consider a very small program. Suppose this is a program in which I have included iostream.h and void main. Now I am declaring a string str of character type, and then I am storing the word computer in it. You can see str is a constant pointer. As you know, the name of the array is always a constant pointer. It is pointing to the first element of the string computer. Now I am saying char star cp is equal to str. It means cp is a pointer of type character and the address of str is stored in cp. So cp is also pointing to c, the beginning of the array or string in which computer is stored. So it is also pointing to c. Now when I say cout str, so this whole computer word will be displayed. Let us understand why. Now this here cp stores the address of str. This is clear. Now the statement cout cp. One thing is there, cout str. This is clear. Now when we say cout cp, again cp is a pointer and it is pointing to the first element of this string str. Now when I say cout cp, this will print computer. Why? It will print the whole word computer. Why not only c? Because when we give the address of a character with cout, it results in printing everything from that character to the first null character that follows it. It will print the entire string, and when the first null character is encountered, it will stop printing. So it will print the entire word computer because the null character will be present here after R. And when we increment cp, suppose now in the next statement C, I have incremented cp because this is allowed. Str++ is not allowed, but cp++ is allowed. So cp++, when I say cp++, as this is a character pointer, 1 byte will be added to it. So it will start pointing to O. Instead of C, it will start pointing to O. So when I say cout cp, again the same thing will happen. It will print all the characters from the current position till the first null character is encountered. So it will print computer. You can see C is missing now. Computer it will print. And this is the output of this program. If you run this program, this is the output. So 2 times when we first display str, computer will be displayed. Then when we display cp, computer will be displayed. And then after increment cp, if I say again display cp, computer will be displayed. Now array of pointers. Like any other array, we can also have array of pointers. A common use of array of pointers is an array of pointer to strings. That is 2D array of character type can be easily declared using array of pointers. Let us see how. An array of character pointer is used for storing several strings in memory. Let us consider a very small code snippet. This is not a complete program. Suppose I am declaring an array of character type in which I am storing pointers, character type pointers. The vehicle is an array of character type pointers, and I am initializing it by values car, van, bus, auto and cycle. So you see the memory representation of this. So memory representation of this, there will be, as I am storing 5 elements in it, there will be 5 elements from 0 to 4, and each element is of 1 byte, which contains the address of the respective strings. So car will be stored somewhere in memory, and the beginning address of car, that is the address of C, will be stored in vehicle 0. Again, van will be stored somewhere in memory, and the beginning address of it will be stored in vehicle 1. Again, bus will be stored somewhere in memory, and the beginning address of bus, that is B, will be stored in vehicle 2. Again, auto, this will be stored somewhere in memory, and the beginning address of the string auto, that is address of A, will be stored in vehicle 3. And the last string is cycle, and it is also stored somewhere in memory, and the beginning address of this string is stored in vehicle 4. So when we use a loop for int I is equal to 0, I less than 5, I plus plus, if I say cout vehicle I, so initially I is 0, so it will display vehicle 0. So when the vehicle 0 element of the array vehicle, an address of the beginning address of the string car is stored, so it will display, as you know, it will display when we say cout vehicle 0, it will print car as giving an address of character with cout, it results in printing everything till the first null character is encountered. So when the null character is encountered, it will stop, and till that, then it will display car as the output. And then next I will be incremented, and it will display vehicle 1, and you can see the vehicle 1, the address of the starting address of van is stored, so it will print the entire string till null character. Similarly, when I is 2, it will print, it contains the beginning address of bus, it will print the entire string till the null character. Then when I is 3, it contains the beginning address of the string auto, so it will display the entire string till the null character. And again, the last element, fourth element, contains the beginning address of the string cycle, so it will display the entire string cycle till the null character is encountered. So you can see it is very easy to handle this array. This is a 2D array, and with the help of pointers, we can in one dimension I can declare two-dimensional character array, which is very easy to handle also. Now I will talk about character pointers and constants. Constant pointer. Constant pointer, it means that address stored in the pointer is constant. There are two things, constant pointer and pointer to a constant. So in constant pointer, the address stored in the pointer is constant. That is, the address stored in it cannot be changed. It will always point to the same address, but the value stored at this address can be changed because the value is not constant. Only the address to which it is pointing is constant. And in the case of pointer to a constant, it means that pointer is pointing to a constant. That is, the address stored in the pointer can be changed, but the pointer will always point to a constant value. The value cannot be changed, however, the address can be changed. Let us understand it by a few examples. Now consider case 1. In this case, suppose I have two integer variables where x is 10 and y is 20. Now when I say int star p1 is equal to ampersand x, it means I am storing the address of x in the pointer variable p1. So when I say star p1 is equal to 20, it means the value which is stored in x will become now 20. Instead of 10, the value in x is 20. And if I give the statement p1 is equal to ampersand y, so instead of x, p1 will now start pointing to y. So in this case, this is a simple pointer. I can change the value as well as the address in p1. Now consider the second case in which I have a constant integer. Const int x is equal to 10. X is the constant integer and y is a variable of type integer only, which has value 20. So if I say const int star p2 is equal to ampersand x, so it means in p2, this is a constant in a integer type pointer to a constant. In this I am storing an address of x. So if I try to change the value of the value which is value to which p2 is pointing, that is it is pointing to 10, I want to make I am trying to make it 50. So this is invalid because it is pointing to a constant number, so it cannot be, the value stored in it cannot be changed. However, I can change the address of p2. I can always say p2 is equal to ampersand y. So now p2 will start pointing to y, and again if I try to change the value, if I say star p2 is equal to 100, this is also invalid because p2 is pointing to a constant integer. So if it is pointing to a constant integer, the value cannot be changed, however the address can be changed. Let us consider case 3. In this you have two integer variables, x is 10 and y is 20. So I am declaring a constant pointer now. So I am saying int star const p3 is equal to ampersand x. It means I am storing the address of x in p3. Now as this is a constant pointer, this is not a pointer to constant, it is a constant pointer. It means the value can be changed but the address stored in p3 cannot be changed. So if I say star p3 is equal to 60, this statement is valid because I am changing the value. So the value of x will also become 60. And if I want to say p3 is equal to ampersand y, this is invalid because p3 is a constant pointer and the location, the address stored in p3 cannot be changed. So this is invalid. Now consider one more case. Suppose we have two variables, again int x is equal to 10 and y is equal to 20. So if I declare a pointer in which it is pointing to a constant integer, and pointer is also a constant pointer. See, const int star const p4. So in this case, the value and address both cannot be changed. So if I say this is equal to ampersand x, so it means it is containing the address of x. So if I want to change the address, suppose I want p4 to point to y now, this statement is invalid because this is a constant pointer. Also, I cannot change the content of the address to which it is pointing, that is 10 to 90. This is also invalid because it is pointing to a constant integer. So this is all for this video. If you like this video, kindly give thumbs up, and you can also subscribe to my YouTube channel. Thank you.